we're solving systems of equations, and we're using the graphing method. Now, to graph these, we need to make sure they're both in slope-intercept form. Remember, slope-intercept form is y equals mx plus b, where m is your slope, and b is the y-intercept. All right. For this problem, we have y equals x plus 5. That is in slope-intercept form. We know our slope is the coefficient of x, so the slope is going to be 1. The constant, or whatever the tail part of this equation is going to be our y-intercept. That is 5. So to graph this, I'm going to graph it in red. I'm going to start the y-intercept. The y-intercept is positive 5. So from the origin, I'm going to go up 1, 2, 3, 4, 5 places and mark the first point. Now I'm going to apply the slope to the y-intercept. Again, the slope is 1. That's 1 over 1. The numerator is the vertical change, telling me to go up 1. The denominator is the horizontal change, telling me to go right 1. So I'm going to go up 1 into the right 1, up 1 into the right 1. From the intercept, I could do the complete opposite. Those are both positive movements. I could go down and to the left, which are both negative, making it a positive movement. Down to the left one, down to the left one, down to the left one. And now I have this line. I'm going to fill in and draw the arrows. Okay. I'm going to make that first line as long as possible because I want to find out where the two equations intersect. I'm not sure where they're going to. So to make the first line as long as possible, figure out where it's going to intersect. Now I'm going to look at my second equation. I have y equals negative 4x. That's also in slope-intercept form. My slope is negative 4 over 1, or just negative 4. My intercept is the origin. It doesn't say plus 0, but we know that it's really plus 0, and that the intercept is at 0, 0. So I'm going to now plot this line in blue. We want to determine where they intersect. So, origin is where our first point is, the y-intercept. Then I'm going to apply the slope to this, negative 4 over 1. That tells me to go down 4 and to the right 1. So down 4 to the right 1. But I don't want to keep going further away from the red line. So I'm going to go the opposite now. I'm going to go up 4 and to the left 1. Up 4 and to the left 1. And now I have my new line. And I can see that those two lines are intersecting at the coordinate point of negative 1, 4. And this is my answer. I can check my answer. To do this, I can take the original equations and substitute negative 1, 4 in and see if they work out. I would plug negative 1 in for x and 4 for y. So I plug 4 in for y, and then negative 4 times negative 1, because negative 1 is going in for x. Negative 4 times negative 1 is 4. Does 4 equal 4? Yes, it does. Let's check the first equation too, because it has to make both right. I have y equals x plus 5. So again, I'm going to put 4 in for y. I'm going to put in negative 1 for x. And negative 1 plus 5 is 4. And 4 equals 4, so it checks out. It makes both of them work. So the solution to this system is negative 1, 4.